One of the most important types of memory in digital electronics and present in all of its instances is RAM memory. RAM memory, random access memory, is a type of volatile memory whose function is different from flash memory, which is for permanent storage. When a processor is executing processes, it reads information from a RAM storage. RAM storage is where we store information like an operating system, or on a smaller scale, the code of a microcontroller. However, the processor, when executing this code, has data that varies with the execution and must be constantly modified or accessed during the execution. In programming, we call these variables. Since, conventionally, we will not be modifying values in the RAM, or at least not so commonly or extensively, where we have the firmware stored, we need another type of memory that offers the exact features for our needs. This is where RAM comes in. RAM memory has the following qualities. It has read and write speeds usually faster than RAM. It has an infinite lifetime in terms of write cycles because there is no electrostatic storage, unlike flash memory which has a limited cycle, usually over 100,000 write cycles. It is volatile, meaning that when the power is removed, the information is lost. Fundamentally, this is how RAM behaves, but there are certain variations regarding performance. Let's look at some implementation cases. In the case of computers, we currently have DDR4 and DDR5 type of memories. DDR stands for double data rate, and they have the following qualities. They are very high density RAM memories, with modules up to 128 GB. We have operating frequencies up to 3200 MHz in DDR4 and up to 6000 MHz in DDR5. This means we will have an extremely high operating speeds. This is necessary given the performance demands of computers, especially with applications like video games, simulation programs, CAD, video editing, etc., where the processing capacity requirements is very high and at the same time there are enormous amounts of data and variables running simultaneously. Now we also have VRAM, found in graphics cards like Nvidia, AMD, Apple, etc. VRAM has qualities similar to DDR, but with some special capacities. VRAM has the capability of simultaneously reading and writing, which provides even faster communication speeds and lower latency, as we are handling even larger amounts of data when dealing with graphics. They are thus optimized for this type of application in graphics rendering. Do you have a project that needs to be finished? Do you have an idea for a product and you want to take it to the next level? We are your best choice. In Prisma Network, we have the best team to do so. We offer services on hardware design and software design. From PCB development, firmware development, app development, and desktop development. We offer competitive prices and an excellent service. Contact us to get a quote. All of the info available at the video description. Now that we have seen this application, let's look RAM at a different aspect, microcontrollers. Microcontrollers having a processor obviously require RAM, but what type of RAM do we use? In the case of microcontrollers, we have SRAM. SRAM or static RAM is most commonly used in embedded applications. This is because unlike years past when we use DRAM, SRAM does not require periodic refreshing of stored data, making it a much faster option for implementing. Internally, SRAM contains arrays or cells composed of 4 to 6 MOSFET transistors, where we have a row decoder and a column decoder, multiplexing the cell array to store each bit. SRAM is found in low storage densities, usually in the range of kilobytes to a few megabytes. This indicates that they are designed for low computational power applications, such as microcontrollers. For example, in the case of the famous Raspberry Pi RP2040 microcontroller, having an ARM Cortex core, it has 264 kilobytes of SRAM. The RP2040 is considered a microcontroller with a very high capacity of processing. If we compare it, for example, to the STM32F103, on our microcontroller it has only 20 kilobytes of SRAM. This is to be expected when comparing the performance and especially the operating frequency of both microcontrollers, where the RP2040 offers much higher performance, hence the greater required and available amount of SRAM. Microcontrollers, due to their encapsulated structure, do not support the implementation of external SRAM modules, as it is not normal to require the same. However, there are other data logic chips like FPGAs that do need external RAM modules. RAM memory is therefore an essential element in programmable data logic, whether in computers, embedded solutions, FPGAs, or any other applications. It can and does become a limiting factor in certain applications, so we must try to choose wisely what we need for application.